Alright, so let's continue on talking about heat, temperatures, and seasons. So basically what we've been saying is this. There's a pattern to seasonality. And the first pattern is that the further north or south you go, high latitudes, North Pole, South Pole, have a greater range of temperatures, right? The other pattern that we noticed is elevation, the higher up in the mountains you go. But the next one we'll talk about is this idea of continental, inland, or maritime locations. And so what that means is this. Let's look at these two cities. This one in Russia and then Singapore. Verkhoyansk in Russia is very far from the oceans and very far north. So its coldest average day in January is about roughly negative 50 degrees. Its warmest day in the summer is about 55, 60 degrees. So it goes from negative 50 to positive 50 and then back every year. Pretty big swing. Whereas Singapore stays about 85 degrees year round. So Singapore has very little variation. A couple things affect this. The first thing is that Singapore is at the equator, 0 degrees, whereas Verhoyens is about 67 degrees north, so much further north, and that's a big part of it. But the other aspect we'll talk about right here is that Singapore is on the ocean. It's surrounded by the ocean. It's an island. And Verhoyens is in the middle of Siberia. It's hundreds of miles from the ocean. So that is also a continental versus maritime effect. Areas that are far from the water are said to be continental or inland climates. Okay, we'll cover these in details, but the four main things that affect it, they all deal with water, specifically specific heat, evaporation, mixing, and transparency. And those all contribute. The lack of water or presence of water affects that. But let's explore this in greater detail. We're going to look at 6 cities and how their seasonality, their swings are affected. So the first one we talked about, latitude. Panama City, number 1. Seattle, number 2. Barrow, Alaska, number 3. They're all right on the coast, so they're the same level of maritime climate. But the big difference here is latitude. Panama City is at 8 degrees north, Seattle is 47 degrees north, and Barrow, Alaska, 71 degrees north. So the further north, the greater that swing of temperatures, that peak. But now let's look at the effect of continents. So number 3, Barrow, Alaska is the coldest. But look at Dublin, Krakow, and Irkutsk. They're all at basically 50 degrees north. So the same distance north or south. But you'll see the much greater swing here in Irkutsk versus Dublin. Dublin is right near sea level. It's actually on the Irish Sea. It's on the coast. Krakow, Poland, is about maybe 200-300 miles away from the ocean. And Irkutsk is about as far as you can get from water on Earth. It's about 1,000 miles from any water. So the further you get from water, the greater the swing. So we talked about water. A couple of the things that do it. And the first big thing is heat capacity. So heat capacity is basically how much heat, how much temperature energy can a material store. And water can store more than land. So what happens is it actually plays out that in the summer, continents become warmer. Even though they can't store as much, they can store it faster. So that means that in the winter they become colder. Heat capacity is this. How much heat must be absorbed by something to make it warmer or colder? So if I have 1 cubic meter of water and 1 cubic meter of sand, how much energy do they have to absorb to increase their temperature? It takes more energy to heat water than sand. And that sounds a little odd because then why would it, in the summer, sand get hotter? I'll tell you why. Here's an example. Here's California in May, and the temperature of the land much hotter than the temperature over water. And that's because, again, specific heat. If we measure that, water has the highest specific heat of almost any object. Okay? So water takes a lot more energy to make it warmer. It can hold more heat because it takes so much energy to make it warmer. We actually use the unit of measurement calorie to measure this heat. To take water, 1 gram, which is a cubic centimeter by centimeter, a cubic centimeter of water, to increase its temperature by 1 degree, make it 1 degree warmer, it needs 1 calorie of energy. To increase the temperature of the same amount of mud, half a degree, and sand that's dry, 1/10 of a degree. So in other words, it takes a lot more energy to warm the water. Secondly, another reason is, as water and land warm up, land absorbs that heat. It takes it in faster than water does. Secondly, as water becomes warmer, one thing it does, it evaporates. And when water evaporates, it cools back down. So it's kind of like this backwards flow. It warms up, cools down. Secondly, because water is transparent, but land isn't, the energy from the sun that warms it up can penetrate much deeper. So not only does the solar energy warm the surface of the water, but the first couple hundred feet, whereas it only warms the top layer of the dirt. It doesn't penetrate the sand. If you've ever been to the beach in summer and you scrape away the first inch of sand, you'll notice how much colder it is. Only the top level of sand absorbs it. And the land can't mix, but water can. So what happens is, it keeps all the energy of heat at the surface, whereas water, it absorbs it in depth. And that's why water takes more energy and more time to warm up. So, that being said, if you look at this line right here, which is directly east and west in the summer, if there was no effect of this, the temperature would be the same at 1, 2, and 3. But because land heats up faster than water, the temperature at 2 is warmer than at locations 1 and 3. In other words, it gets warmer over land faster, and it bends these temperatures up this way north. In the winter, it's the exact opposite. This area here is furthest from the water. This area is colder than locations 1 or 2. Another thing that happens is that oceans not only can absorb the heat slower, they hold it longer, and if the water moves, it takes the heat with it. So we have these ocean currents that transfer heat. One of the most famous ones we'll talk about quite often is the Gulf Stream. It's this current of water that goes from the Gulf of Mexico all the way to Norway. And as it moves north, it pulls the heat that it gathered in the Caribbean with it. It transfers it. In fact, that is the reason why Northern Europe is much warmer than it should be otherwise. The currents actually raise the temperature. So near the ocean, you have a much better chance of these warm currents changing temperature. There are cold currents. They're not as influential, but they are around. We'll talk about those in about 4 or 5 chapters. But here's an example. This map shows the surface temperature of the ocean. The darker the red, the hotter it is. And the current here, the Gulf Stream, you can see this kind of orange streak right here, goes north. So when you look at Norway, right here, Tromsø in Norway and Barrow, Alaska, are the same distance north and south. But you can see that it's a little bit warmer here because all that warmth being pushed into Europe because of the Gulf Stream. People don't realize this, but London, England, which is warmer than Chicago, is the same distance north and south as Hudson Bay in Canada. Another thing that affects this is wind. Wind can also blow temperatures. It can blow warm air. And if the wind generally blows from warm water to land, that coast is warmer. And generally speaking, in the world, the major winds blow from west to east. So most of the western coasts of the world have warmer, wetter, maritime climates. And eastern coasts have more, what they'd say, continental climates. It's strongest in the mid-latitudes, which is where we are. Let me show you an example. Generally speaking, at this distance, this is about 45, 50 degrees north. The wind blows from the Pacific Ocean across North America to the Atlantic. So the western coast gets air that's blown by the wind over water, which is warmer and moister. So Crescent City, which is the same distance north as New York, has a much more maritime, much more mild climate than New York. Because by the time that air blows over this cold or warm, dry air, it's much different. So generally speaking, we see wet maritime climates on western coasts. So, all of this stuff put together, we can make these kind of maps. This map shows you the average temperature range. The darker the red, the little the variation. So in other words, in this area, the temperature during the year never changes by more than 3 degrees. It stays roughly 3 degrees, right near the equator. The darker the blue, the greater the range. The greatest annual temperature range in the world is right here in central Siberia, because it is far north and far from water. So you can see the further you get from the ocean, the greater the range. We also see, right, these seasonal kind of more mild climates on western coast, the western coast of America, the western coast of Africa and Europe, less so here. All right, we're going to pause right here. So when we come back, we'll be talking about the sun.